Okay, we should be on page 8 of our Unit 13 packet where we'll be talking about reference angles today. A reference angle is an acute angle formed by the x-axis and the terminal side of the angle. So before I begin on the two examples below there, I'm going to generalize how to find a reference angle in each one of the quadrants. So I went ahead and added a sheet of paper. If you guys can go ahead and grab a sheet of paper. I drew in an XY axis just so it's a little bit faster for me on my end. So we have an example on what happens if the angle's in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So in quadrant 1, what that angle would look like would be initial side is on the positive x-axis. The terminal side is on somewhere in quadrant 1. This is my angle. In quadrant 2, initial side is always on positive x-axis. Terminal side is in quadrant 2 with it being an obtuse angle in quadrant 2. Quadrant 3, the initial side is on the positive x-axis, terminal side in quadrant 3. This is an angle beyond 180 degrees, so that's theta. And then quadrant 4, initial side on positive x-axis, terminal side in quadrant 4, and that's my theta past 270 degrees. So now I'm going to highlight all my reference angles, but a reference angle is defined as the terminal side, the angle formed by the terminal side, and the x-axis closest to the terminal side. So in this case, what I highlighted was the original angle. So to find the reference angle, which I'm going to call theta subscript r, as this is my reference angle. To find my reference angle, for this one, it happens to be the same as the original. In quadrant 2, we see that the reference angle, when defined as the terminal side and the side closest to the x-axis closest to the terminal side, the acute angle formed by that happens to be the supplement of the original angle. So when I am in degrees, to find my reference angle, I would take 180 degrees and subtract out the original angle. If you're in radians, you would take pi minus the original angle. So in quadrant 3, I see that I've overshot the x-axis. So in this case, I have my terminal side. In the third quadrant, my x-axis closest to the terminal side is the negative x-axis. So to find the reference angle in this example here, or in quadrant 3, we would take the original angle and we would subtract out 180 degrees or pi to figure out what that acute angle measure is. And lastly, in quadrant 4, we have the reference angle being the terminal side and then the x-axis closest to the terminal side. And so we have an angle that is greater than 270 but less than 360. So to find the measure of my reference angle here, I would take 360 minus out my angle. So let's go ahead and take a look at an example. For this one, we're going to go ahead and find the reference angle for 5 pi over 6. So angle should look familiar to you guys. We've talked about dividing half of a revolution, pi, into sixths. So in this case, when you reach pi, I always like to think of it as dividing pi or half a revolution into sixths. So if we do that, then when you get to pi, you now have 6 slices of pies. Okay, so and what I want you to picture is 1, 2, 3 being there, 4, 5, and then 6 pi over 6 being here. So what I'm looking at now is that 5 pi over 6 is, in fact, not that one, not that one, not that one. I accidentally erased my my coordinate point here, or my XY axis. So when I'm picturing 2 pi over 3, what I'm going to, or 5 pi over 6, I am picturing this angle right here. Okay, and so the reference angle is, again, the terminal side and then the x-axis closest to that terminal side. So we're trying to figure out, well, what is that angle right there? Or how close is it to 6 pi over 6? So by definition from above, to find the reference angle, we would take pi, or 6 pi over 6, and subtract out the original angle, 5 pi over 6, to get that the acute reference angle is pi over 6, and this is that measure here. Informally, I always think of it as how far away from the x-axis are you? So let's take a look at the examples that we have on page 8. On page 8, the first example asks for 5 pi over 3. Well, I'll notice that it's over 3, which means I'm dividing pi into thirds. So when I'm counting, I'm thinking, okay, well, this is 1 pi over 3. This is 2 pi over 3. This is 3 pi over 3 here to get 3 slices to pi. This is 3 pi over 3. This is 4 pi over 3, so 5 pi over 3 is here. And so what I'm going to do is now just sketch out what 5 pi over 3 looks like. It would be, initial side is here. We're going to revolve to 5 pi over 3. And the question is, what is the reference angle? With the reference angle being the terminal side, and then the x-axis closest to the terminal side. So you might be already thinking that, well, by the time I make the full revolution, I'm going to have 6 pi over 3 or 2 pi as the full revolution. So if I'm trying to find the reference angle, I'm taking 6 pi over 3, subtracting out 5 pi over 3 to get that the acute angle measure is pi over 3. Why don't you guys pause and try the next example? So for the next example, you would have noticed that 510 is over 360. So we've made one full revolution. And to find out where that leaves us, if we subtract 510 from 360, we get 150, which means that we're 30 degrees shy of 180 degrees, which would lead us into the second quadrant. And just saying it that way, we're already finding the reference angle informally. So finding the reference angle means that we're finding, again, the acute angle formed by the terminal side and the x-axis. So in this case, we would take 180 degrees minus out that 150 to get that the reference angle, the acute angle, is 30 degrees. And again, it's always how far am I away from the x-axis.